Hi guys. Today what I want to do is give you a quick tutorial on how to use Troy Hunt's Have I Been Pawned Passwords API. So what this is it's a way um, to tell your users if a password has been found in a data breach before, if it's been exposed through a data breach. So first let me explain how the service works, and then we'll dive into some code and show you how to implement it. So first thing, we go to the API webpage, haveibeenpawned.com /API, and we're looking at version 2 of Pawned Passwords. Troy has this blog post that I really encourage you to read. That this blog post gives you a lot of insight into why Troy did it this way, as well as a couple organizations that are donating their service for him so that he can provide it fast, efficient, and for free. So it is a free service, like I said, and along with that, it's not rate limited. Okay, so for this particular API, he's not throttling the amount of requests that you can make. All right. So the first key thing to note is that we're not actually going to send the password over the wire to Troy's API. Okay, what we're going to do is we're going to create a SHA-1 hash of the password, and we're going to send that over. And then Troy's going to tell us if that hash is in his system or not, in his database. And even with that, if you look at the API request here, we're only sending the first 5 characters of the hash. We're not even sending the full hash. So this is actually pretty genius what he's doing here. So if you think about your hash, we're going to divide the hash into 2 different substrings, a prefix and a suffix. So we pass into Troy the first 5 characters, and then he returns back a list of every hash every hash that begins with those 5 characters that's in his system. Okay, so for example, in this example here, what has been passed in is 21BD1. All right, and Troy does his query off of that and returns back this list. Now notice that we're not getting back that prefix, we're only getting back the suffix, and then it's on us to compare or to find our suffix in this list. And then he also tells us how many times the password has been found in his database. So this is actually really clever, right? Because not only now do we not send the password over the wire to Troy's API, but we don't even send the full hash, right? We only send the first 5 characters of that hash. So anybody could get this URL and it's useless, right? It does not expose any passwords doing it this way. So that's really a clever solution to keeping that extra level of security there. Okay, so that's the rundown of his service. So now let's look at some code to see how to implement it. All right, so let's take some notes off his documentation here. Let's take some notes of things we're going to have to keep in mind when we're writing the code. Okay, so first we're doing a get, so we know we're going to have to do an AJAX call. Also, we're passing in the first 5 characters of the hash, and along with that, we're looking at the suffix of the hash. So that means we're going to have to first create the hash, then we're going to have to split the hash by the first 5 characters and then everything else. Then let's look at the result set. The result set is a list of hashes. They're separated by the new line character, and each result has a colon followed by a number. All right, so once we get into our list of hashes, we're going to have to split the result on new line to get our array, and then once we as we iterate over that array to do our comparison checks, we're going to have to split each instance by colon so that we can then do a true compare between what our suffix is and the suffix that Troy has returned to us in this result set. Okay, so first let's think about what it's going to take to generate the hash. We know that we need a SHA-1 hash. All right, so how are we going to do that? There's two ways, right? The first way is we can pass the password back to our server and let our server create a hash, let our server either then send the hash back to the client, which can then do an AJAX request, or the server can take the hash and do a REST request over to the API, get the result back, parse it, and then send back maybe a Boolean or a count back to the client. All right, so that would be one way to do it using the server side. But I think that it would be better if we can do it entirely in the client. Okay, so in the client, if isolated to the client, now we don't have to send anything over any wire, not to our network, not to Troy's network, not to anybody. All right, let's eliminate man in the middle entirely here. Okay, so what we'll do is if we can create the hash on the client, then we can do simple string manipulation in JavaScript to get our hashes and so forth. Well, it turns out there's actually a library that will let us do that. So if we hop over to GitHub, we can look at Emin178. He has this library, or she has this library called JS-SHA-1. All right. Now, what's nice about this little utility is it's not dependent on anything else. Okay, we can do all of our stuff in vanilla JS. We can use jQuery, we can use React, we can use Vue or Angular. Whatever you want to use is fine because there's no dependencies. There's zero dependencies. And this is very simple to use. All right, we can look down at some examples. You just create a SHA-1, you pass in a string, and you get a hash. And this library does all other things as well. It supports UTF-8 encoding. It supports creating a byte array, or different types of outputs. We can do an array buffer, a hex. But we're not interested in any of that. For our purposes, we'll just stick with using the basic usage where we pass in a string and we get a hash back. All right. So before we show the code, I want to show you. I already have a form wired up that we're going to implement this on, and I want to show you that it's not wired up at all. Right. So I type in something, I click submit, and you can see nothing happens. Okay. So there's nothing wired up right now. So while we're on this, let's talk about where you would implement this. Okay. The two obvious places that you would implement this are on your user registration page and on your user reset password page. Okay, because the idea behind this service is that we want to deny a password from being used in our system if it's been found in a known data breach. All right, so this gives us a mechanism to keep our data clean because we know that as humans, we all have bad password tendencies, right? If we don't now, we did in the past, right? So we want to help protect our users, all right? And by doing this, it's practically zero cost to you, and it's zero cost to your consumer. As you see, once we implement this, it's very instantaneous. It's super quick. All right, so you're not going to be adding a bunch of load or anything like that to your response times. And Also, there's an added benefit as well, all right, to your user. Um, because we know that people reuse passwords, and even if the password that is found in this breach is not reused by this user, all we're simply telling them is the password that you've entered has been found in a known data breach. So if they've used the password before, or if they've never used it, and it just so happens that somebody else has used it, okay, now what we're telling them is this isn't a good password. So go ahead and create a password that's unique. But in doing so, if they have used it somewhere else, say at their bank, or say some other institution, some other organization's website that is not secure, because you can't control the the hashing techniques or the password storage techniques of other sites. So maybe they're using the same password somewhere else. So if we tell them that this password is part of a known data breach, maybe, just maybe, we will be encouraging the user to go and change their password other places. At the very least, we're not going to allow the password on our site. It's not going to be allowed in our system because it's going to be deemed forever a bad password. So along those lines, let's think about now the framework, the mindset of customer benefit. It also makes sense to put this on your login screen, okay? So this is a zero cost benefit to the user. Again, they log in, their password is safe, it's never been used in any other data breaches or not been found in any data breach. So you let them in, no problem. They don't know anything happened, right? But they log into your site and they're told now that their password has been found in a data breach and they've reused that password. So what you're telling them is another site that they've used that password on has been breached, and so they need to change their password over there. And it's not necessarily that. Again, it's not necessarily true that they have reused the same password. It is possible that it is a kind of generic password or a password that's not unique enough, and someone else has used it as well. And somewhere that person has used it, it has leaked or has been exposed in a data breach. So that's entirely possible. But either way, what we want to do is treat it just like they're registering for the first time or just like they are resetting their password. We want to say, okay, we're going to let you in this time. But before we let you in, you need to change your password because your password has been found in a data breach. And we want to keep you safe. That's our top priority. And so we're going to make you change your password to another password that has not been found in a data breach. All right. So with that, let's switch over and take a look at some code. So this is that form that we have that we had wired up there. So let's first take a look at what we have. All right, we have a password input box. We have a button whose name is button, ID is button, and we have a div whose ID is result that we can now send our we can spit our result, a message back to. Now I've injected jQuery here. This is not a video where I'm suggesting the use of jQuery or I'm suggesting the use of not jQuery. But just to simplify our code a little bit, we put it in here to give us some of those syntax helpers that jQuery has famously provided. So the first thing we want to do is add a script tag where we bring in that SHA-1 library. Okay, so that is called SHA-1.js. Okay. And now we'll create another script tag to do the actual work. So let's start by creating a window onload function or a document onload function. So when our document's loaded, then we will execute this code. All right, so let's think about what the flow is, and let's think about what we're trying to achieve, and let's write it out as a list, okay, so that we make sure we get all of our bases covered. All right, let's start with the end result. The end result is if the password has been found in a breach, display to user the following message: the password has been breached, and I will say along with the number of times. Along with how many. Okay. So if so the inverse of that is if the password has not been found, display to the user. Scroll up here. A message. Just for our demo purposes, we'll say the password has not been breached. Okay. So how are we going to do this? Well, the first thing, the user is going to type in a password. They're going to type in something, and then we're going to click the button. All right. So we need to on button, click, do these things. All right. The first thing is create a SHA-1 of the input, right? And then we're going to create a prefix, which is the first 5 characters. And then we're going to create a suffix, because we need that later as well, which is the remaining characters. All right. So once we've done that, then we need to pass the prefix into that API. So we'll do an AJAX call, get to HTTPS API dot pwnedpasswords.com/range, and then the prefix. Okay, and then with the result, let's see. Then we said we need to split the result on the new line character. All right, and then we need to iterate over the array, and we need to split again each instance by colon, and then do a comparison. All right, and then that brings us to our end result. Okay, so let's implement this. Okay, so the first thing we need to do is create an event handler on our button, and in jQuery we do that by locating the button. We'll do it by ID, and we say on click, and we're going to pass in a function. Well, there we go. That is rendering funny looking. Okay. All right, so we've got our button click. So what's the first thing we said we have to do? First thing is create a SHA-1 of the input. So first we have to create a SHA object. Let's just call it SHA. Our example said that we can just do SHA-1 and give it a string. Our string will be the password field. Okay, and then we'll normalize to uppercase. And now we need a prefix, which is the first 5 characters. So var prefix equals SHA.substring. Start at position 0 and give me 5 back. And now we need a suffix. So SHA.substring. Again, this time start at position 5. Remember, we're 0 index based, so position 5 is actually character 6. And then give us the remainder. We could count that out, but we'll just do SHA.length. It's okay if it's too many, because substring will narrow it down. It doesn't care. And then we have that. All right, so let's get rid of some of our comments here. We've got our unbutton click, we've got our SHA, we've got our prefix, and we've got our suffix. All right, so next we said we need to create an AJAX request to that API. So let's do that. And jQuery gives us this nice AJAX helper that we can use. All right, we pass in the URL, so that's HTTPS api.pwned.passwords.com/range, and then we can append prefix to that, and that's all there is to that. Okay. Oh yes, don't put a semicolon there. All right, and now we use the AJAX done handler, and so we'll say that is equal to function response. All right, so let's get rid of this here. Let's bring this in a little bit. All right, and get rid of that. All right, so first thing we need to do is split on the new line character. So var hashes equals response.split and go away on new line. All right, and let's go ahead and create a variable here called breached that we can use to track the state. And we're going to default that to false. So the reason we're going to do it like this is inside of our loop, we're going to loop over each response from the API, and we're going to compare that response to our suffix. And if it is a match, we're going to spit out a message to the to that results div. We're going to break out of our loop, and then outside of that loop, we're going to have, we need a way to show that the password has not been found. So outside of the loop, we're going to check for this breached boolean, and if it is set to true, which we'll do inside of our, if it's not set to true rather, which we set it to true inside of our loop on a match. So if it's not set to true, then we're going to display the message, your password has not been breached. There's other ways to do that, but this is one way that you can do it. There's other ways as well, but we're just going to do it this way. All right, so let's start a loop. We'll do a simple for loop. We'll use I as our indexer, or as our iterator indice, and we're going to say 0. And while I is less than hashes.length, So here we are inside of our for loop. What did we say we have to do? We have to split each instance by colon. So first let's get the instance. So let's say var hash equals hashes with the index of I. And then let's do our split. So we'll say var, let's go hash suffix equals hash dot split on colon. Okay. So now we're going to do if I don't like that variable name. Let's do var let's just go var h. Then we can do if h first index, which is going to be the suffix. So if that is equal to our suffix, then let's load a message into our result div that says the password has been breached. And that go away. The password has been breached. And we can now, so we know anything after the colon is the number of times. So we can do the first index times. All right, so we've got a match. So we've set our result, our HTML to the result div. Let's change our variable to true. It was breached. And then let's break out of our loop. All right, so outside the loop, if we get to here, we've either, like that. If we get to here, we have either broken out of our loop or we've finished the loop and we didn't find a match. So we can, that's why we do this check for not breached. And so now we can pass into our result div the message password has not been breached. All right, so let's look over our checklist to make sure we've gotten everything. Split the result of on the new line character. We did that. We iterated over the array. We split each instance by the colon. We did a comparison to detect the password found or not found. All right. We said if it is in a breach, display to the user the password has been breached, along with how many times, and we have done that. And then lastly, if it has not been found in a breach, display to the user the password has not been breached, and it looks like we've done that. So now we should be ready to test this. So I'll save it, and let's pull our form back up and do a refresh here. And let's see if it works. There you go. So what I typed in there was QWERTY, K-W-E-R-T-Y, which is evidently a very, very bad password to use. It has been breached 3,912,816 times. So as you can see, that was extremely fast and efficient, and it worked. Let's try QWERTY01. We're getting better. 13,935 times. QWERTY01 exclamation point at. That password has not been breached. Okay, so there you go. Switch back to the code so you can look at that while I finish up. While we wrap up here. Make it a little bit smaller. Hopefully you can see all that. So that's it for this video. I hope you've enjoyed it. Let me know what you think about this API. Let me know Um, I'm curious to know. I'm sure there are better ways to implement this, so I am curious to know what you think about that. So leave your comments below. If you did like this video, or even if you didn't, subscribe, and you'll know when I have more videos like this in the future. All right, y'all have a great day, and we'll see you next time.